We're going to be recording this one because there was a request, right, Kevin? There was a request for recording. So, but usually we don't. But let's see how it goes. Anyway, welcome again to our try to do a monthly, right? Lunch and learn from the Orlando Machine Learning and Data Science Meetup. So let's go from the agenda. We usually, the purpose for people that are joining us today, the purpose of this meeting is to share some situations, some knowledge in the data science field. Okay, as we mentioned, we have our formal meetup. Pre-COVID was in person. Now we're doing it also virtual, and we'll take care of that in one of the announcements. We go through introductions, so we like to know a little bit about who you are. Then we have the announcements. This time I'm going to be talking. I'm your host and speaker. I'm going to be talking about how to deal with missing data and values in a data set. Okay, and also let me remind you that we keep the discussion in our Discord channel, and I'm going to provide you in the chat. I'm going to provide you the link. So if you haven't joined, you are mostly welcome. In fact, some of the things that we're going to discuss, because it's just an hour, probably we'll try to keep it right. Try to keep it ongoing in the Discord. All right. So introductions. Let me start by myself. My name is Ricardo. I'm, my regular job is not in data science per se, is more in appraisal. I do real estate and also personal property appraisal mostly down in Puerto Rico. I don't do appraisals here in Florida. So, don't ask me about the price of your house or anything. I really don't know. I really don't know. Okay. So I started this journey about 2 or 3 years ago. Okay, because my background is in industrial engineering. I did a lot of years in manufacturing and maintenance, and I just got that inkling of trying to learn a little bit more about the R environment, R programming language, and every things got along, and then I met Kevin, I met Ron in the OMLDS, and that's how we have kept the ball going. Kevin.
Hi, I'm Kevin, one of the organizers of the meetup. I was a data scientist for 4 years. Now I work for a company called Prefect. Prefect is an open source workflow orchestration framework, Python based still, so it integrates a lot with the PyData stack. Yeah, I think that's it. I've been around this meetup for maybe 4 years now or something like that. Yeah.
Yep. Okay, and anyone else that wants to say hello?
Sure. Oh, go ahead, Michael or Mitchell.
Mitchell, yes. Mitchell, go ahead.
Hi, I'm Mitch Katz. I'm with the Water Science section of the Orange County Environmental Protection Division. I'm serving the public as the technical program director. And basically what we do is we characterize the behavior of watersheds, look for impaired water bodies resulting from changes in land use. And we're very intense. We're data intense, a lot of boots on the ground, collecting flows, collecting loads, collecting nutrient concentrations. And we dump this data into a LIMS system. And so in a previous life, I did a lot of air quality modeling and groundwater modeling using like USGS models and EPA models, finite state models, things like that. Flash forward, I've been trying to get to the point where I can model the behavior of these watersheds with this data set and then forecast how new changes in land use will affect water that currently is attaining water quality standards kind of assess the risk and that kind of thing. So it's really caught fire with me, and I just wish I never had to sleep. I just go ahead and do this all the time. But
Right.
that's kind of where we are. Thank
Okay.
You should talk to Dan. We have a guy who's
Yeah.
active in the meetup also, Dan Schmutz. He works for an environmental consulting
Right.
firm, and like I remember he made the presentation about what was his present, like the water lines with like
Kriegel. I remember
flooding.
the Kriegel regression.
Oh yeah,
Remember?
yeah. But he was
Yeah.
doing some kind of like predicting where the water line will be in the for like
Right.
yeah,
From
the and like
from
how that affects the environment, right? Yeah, I also
exactly.
used to work for the USGS. I started out researching with the USGS because my bachelor's and master's are in water resource engineering.
Yeah, that's very topical in Florida right now,
Oh yeah.
especially with global warming. The intrusion of the salt
The
water in the
intrusion of
water
the
table.
saline intrusion. I was thinking about that. Yeah. Yep. Okay. And next.
Sure. My name is Ron Bergeron. I've been doing IT work for almost all my career. I've been in software development, database administrator. I've led small IT teams. And then starting back, I don't know, somewhere around 2017, 18, I started to get interested in machine learning a little more. The job I was prior in, I led that IT department, and I initiated some business intelligence and left them with a model, a machine learning predictive model for some of the uses there. And in 2019, I got involved with OMLDS here and the volunteer project that we did with the foster care system in Orlando. I created my own startup company around that same time. And then in 2020, just as COVID was getting started, we ended up getting into a project. Kevin and Ricardo were involved also, that we did a model that helps set a complexity score for foster care cases so that the system can better distribute the caseload amongst their caseworkers. And that's been going on. I've been doing that for since April of 2020. And it's in a couple pilot locations right now. And hopefully we'll see that roll out to more agencies across Florida.
Good, Ron. And anyone else?
Hello, can you hear me?
Yeah, a little bit low, but we can hear you.
Oh, sorry about that. I thought my mic
Tom.
didn't work. Yeah, hi. My name is Tom Lee, and I am new to Florida. Actually, I moved to. I'm in Sarasota, so not quite Tampa.
Okay.
I have been a information security architect. Been in cybersecurity for too long, and I realized the importance of using data and analytics to prevent potential attacks. Right now, I'm working for the central bank and trying to use machine learning. Actually, I took some online courses, but tell you the truth, the only thing that I've done okay is the Titanic prediction. I tried to use some data loss prevention data, but I guess I was trying to chew more than I could bite.
Right.
So I'm still learning, and I'm hoping to learn from everybody. Thank you.
Okay. Excellent. Anyone else?
I can go ahead. Again, my name is Burak Kankaya. I am an assistant professor of business analytics in Embridle. And I have been doing research on data science and utilizing machine learning techniques, I think, for the last 8 years now from my graduate school. I mostly work on aviation problems. It varies from prescriptive analytics and descriptive analytics and predictive analytics in all of 3 areas. I live in Orlando for last 4 years.
Okay. Welcome, Burak.
I think it's my first time meeting this group.
If you join Discord, we can talk a little bit about my previous, appraisal job, which was, appraising some Britain Normans. I don't know if you are aware of them. They are from the UK,
Okay.
but they are a challenge because there are not many flying around. So, yeah, we can talk a little bit about that one.
Yeah, I'll join to the group.
Yeah, excellent. Okay, anyone else that wants to introduce themselves?
Hey everyone, this is Connor. I am a software engineer at a local company to Orlando called SitePlan, and I've had an interest in data science and machine learning for the past 3 to 4 years or so, but really only started getting or formally educated over the past year while I've been taking my master's at Georgia Tech. And this is also my first meeting.
Okay, welcome.
I'm a Georgia Tech grad, industrial
right.
engineering 95.
Oh, nice.
Yep. We have the what is your mascot there? The Georgia Tech. It's not the Bulldog, right? The Bulldog is.
Oh no.
Okay, those
No,
are
it's
your
Yellow
folks,
Jacket.
right?
Yes, we're the Yellow Jackets.
Okay, there you go. Okay, and anyone else? And to give equal opportunity to everyone that is joining us.
Yeah, this is Florence. This is I think second or third time that I attend one of these meetups. I am a programmer. I work for DTCC in the Tampa office. I used to live in Orlando, or well, closer to Orlando, and I am a member of Code for Orlando. So I'm also interested in artificial intelligence, machine learning, but I'm not actively doing anything to learn other than just attend some meetups because I'm busy with other things. But I guess sometime in the future I'll go a little bit deeper in that.
You'll jump in. Okay, excellent. Okay, anyone else? Okay. All right. So a couple of announcements. Okay, a couple of announcements. Okay, yesterday I was in a webinar about a person. Her name is Melissa. Okay, and I posted. I'm going to post this in the Discord. She's part of the scipy.org. Okay, scipy is a Python library, for scientific and mathematical algorithms. And it was interesting because they're asking, programmers, data scientists, the community to contribute to SciPy. Okay, so that link is the webinar, is the YouTube webinar. If you're interested, okay, especially research, or you're doing your master's or even your PhD, maybe you should be aware of this, because part of the networking is trying to get the same people and trying to get some contributions there. So check it out. It was really really interesting. It's not that easy to contribute. You have to learn a little bit more about how they do things, but it's something, a learning curve there. Then also yesterday there was an interesting talk in the Orlando Python user group. Okay, that's headed by Michael Dupont. He was talking about an initiative from Anaconda that now Anaconda has released what is called PyScript. Okay, when you interact with a web page, you usually interacting with the HTML, but also interacting with JavaScript, right? Okay, the language that really powers that page. So PyScript is basically JavaScript but with Python. Okay, so now you have the opportunity to run your Python scripts natively in the browser. Okay, and that's very interesting. Right now, it's just an early, at the early stage, so it's kind of slow. It's not ready. We talk about it, and it's not ready for production. But at least for people that are entering, the data science field, and usually you should be acquainted with Python because that's one of the major languages that we use for data science. The good thing is that the barrier to enter to know Python is very low because you don't need to create an environment to run this. Okay, so it's a very interesting, initiative from Anaconda. And for those that don't know Anaconda is one of the, one of the organizations that facilitates the creation of what is called virtual environments. Okay, the Conda environment. So, I just want to, people to know about it because it has some, interesting potential. I don't think it's going to replace JavaScript, in the near future, but at least it will be an alternative. And they have some demos, really interesting demos about how to use it, within the browser. Then May 31st, okay, I'm not going to be around because I'm going to be taking some vacation in Washington, DC. But May 31st, there's an invitation in Orlando Devs for the Google I/O event. And they're inviting, the developer community at large to participate in an in-person, like a get-together, because that's what it's called, the Google I/O Extended. And it's going to be at 7 o'clock. I believe it's going to be near Alafaya, East Orlando. So I'm going to also post the link there. And we have, Kevin is going to announce the next virtual meetup, a formal presentation. I believe his name is Jacob Barak. He's from, he organizes the Austin, machine learning and data science meetup. So stay tuned because there's going to be an announcement about that. Okay, so those are the announcements. Okay, let's see here. And I'm going to post also in the chat when I, get out of the presentation mode. I'm going to post the link for the Discord. That's our channel. That's where we hang out. And I want to, invite you there, continue the discussion, because right now I'm looking at my clock here, and it's 12:23, and I don't want to, intrude in anyone's schedule. So we have until 1, whatever we are, we're until 1, to discuss our main subject. Okay. Okie doke. So let's see. I told you that I'm not going to post this. All right. Okay. Discord. That's the Discord link. Feel free to join. Okay, so let's start with our discussion of today's topics, which is missing values, right? Okay. Okay, so that's the main subject that we're going to be discussing, for the rest of the meeting, is to introduce you to some missing data concepts, diagnostics, and some possible treatments. Okay, so let's start with the first thing. What are the objectives of this presentation? First of all, we have to define, at least get a good idea of what is, what do we mean by missing data? Okay, then we're going to discuss some of the missing data, what they're called mechanisms or diagnostics, in terms of what is MCAR, what is MAR, and what is MNAR. Okay, and then we're going to do some, scripting in terms of how to deal with the missing data, usually the right way. Okay, in other words, the data science way. Okay. So let me start asking to the audience, what is for you missing data, missing values? What is it? What are we talking about? Don't answer all the time. Anton.
Yeah.
Hey.
I'll jump in. Oops, sorry.
Yeah.
I'll
Go
just
ahead.
jump in here. Quite often we run into, continuous readings. That continuous record is interrupted because of field, equipment that fails in the field.
Right.
And also we get laboratory results back that are qualified. Either they are say the chemical component is undetected, and so we substitute that value with half the method detection limit, or it's between what can be detected and what can be reliably reported.
Right.
And then sometimes, the result has interferences or it's blown off the scale. And so you have to make those judgments as to what value you use when you go to work up the data.
Excellent. Excellent. Anton, I think you wanted to chime in.
Yeah, sure.
Yes.
So,
how are you?
Splendid. Thank you.
Yeah.
Well, I guess now I want to give a different example. Like I was working for Racetrack Petroleum, or like they have around 600 gas stations around US. And I was responsible for the optimal distribution of the fuel around the stations. So imagine they take some fuel from Tampa and they want to, transport it to Jacksonville, Miami, and so forth. So, well, in Florida, this doesn't happen, but in some of the other states during the winter, the sensors, they get frozen, right? And so they cannot actually figure out, well, they kind of see what is the levels of the fuel in the reservoirs, in the ground, which are the stations, but they're obviously wrong, right? There's no, and so to some extent they did try by sensor-wise to say, okay, this data is missing. But then I was saying, look, actually, I would rather kind of see it, see what the level is there and then make an inference for it. But basically, I worked with, I had different types of sensors were updated and upgraded at different times of the throughout the lifespan, right, of the gas stations. So you have like this mixed data in which the wrong values are either, they're either wrong values in the present or they're just missing, right? And so it for me was actually trying to infer what are the missing values. This one of the things I would say. The other is from weather forecasting and air pollution. This is systematic because they just put some balloons which are being blown around, right? And so you make some regular grid and you try to reproduce the wind fields. You just cannot. These are just balloons which are blown by the wind patterns, wherever, right? So in a sense, you always have this missing values and etc. You need to do some imputations using some physical principles like conservation of masses, or the winds, they have some kind of gradient, a divergence type of properties. And so in a sense, you have to complete the missing data, say from, I don't know, like say from 200 to 2000 trajectories of different balloons with wind speeds. You need to kind of reproduce what are the different concentrations, say, across all of US on some rectangular grid.
Correct. Okay.
Thank you.
So I guess some people in our audience are very knowledgeable of what causes, right? What causes that missing data, the missing value. And usually what happens is that when we start working with data, we start noticing certain values or certain features that there should have some value and it's not there. And then you have to analyze, why is it there, etc. And you have to do your research. Okay. Also picture a donut. Okay. The donut, they come, as full. If you go to, Dunkin' Donuts, and you say, let's say, you say like a, full donut. I don't remember the brand, but you can have a full. But sometimes the donuts, and it's the donut that we usually picture in our mind, is the one that has a hole in the middle. Okay, so that hole in the middle is you're missing. It could be you're missing value or you're missing data. Okay, so what are the mechanisms that explain why the data is missing? So this is a paper from Little Rubin back in 1976 that classifies the mechanisms of missing data in three categories, okay? The first one is missing completely at random. In other words, our data, and there's going to be a proper definition in the next slide, but the data, it has like a random pattern. In other words, there's nothing that is in the data set that can explain the missingness of that value. Then we have the second category, which is missing at random. I'm going to explain what it is because sometimes the terms, just by the definition, you can get confused. Okay, there's missing at random, and there's missing not at random. Okay, the MNR. So those are the three, according to Rubin, those are the three main categories that you have to explain, or mechanisms to explain your missing data in your data set. So the first one, missing completely at random. This is the one that, as I explained before, your missing values are purely at random. And you can simulate this, okay? You can have any data set and you can simulate random numbers, picking places during the day in the data set, and picking, and just putting in Python will be an N, or in R would be an NA. Okay, and you can replicate that and do some kind of experimentation. The example here for the missing completely at random is when a weather sensor, okay, and it's interesting because some of the examples that Anton and Mitchell gave were of equipment. So a weather sensor is measuring temperature and sending the data to a database. There's some missing entries in the database for when the sensor broke down, okay? So if that breakdown is not, it doesn't have a pattern by itself, we could, assume that that missing data from that sensor, or that missing reading from that sensor, could be random. The problem with the MCAR is that usually your missing values don't, pass this test. There's a statistical test from MCAR, and usually, from my experience, usually there's some pattern, underlying pattern within your data set from the missing values that then, precludes that MCAR is not the mechanism that you are, that should be applied to it. Okay. Then, what is the next one? Missing at random. Missing at random. So this one is when some of the missing values in your data set depend, and that's the key word, depend on some other observed data. In other words, you have, let's say, temperature, right? You have missing readings, but then you notice, okay, and that's the example that it gives right there in the slide. You notice that there's a pattern in terms of the days that that missing value is occurring. Okay, so you have temperature feature, and then you have a date, okay, or even an hour within that date. So the explanation is that that sensor is being maintained during the weekends. So in other words, it's turned off during the weekends, and then because it's turned off during the weekends, then it's not going to transmit at the certain rate that usually transmit during the weekdays. So here it depends on some other observed data that you can, that you can insert. If it's not in the database, at least you can insert that information. Okay. Then the most curious one is the one that it says missing not at random. Okay. And this one is the mechanism where those missing values in the data set depend on the missing values themselves. Okay. In other words, they don't depend on other observed data. They depend on the missing values themselves. And I believe that Anton, basically talk about this. Okay. He was talking about the case of missing not at random. And he says that the example is when it's extremely cold, the weather sensor, let's take the example of Anton, the weather sensor for the fuel, fuel tanks, the weather sensor freezes and stops working. Okay. So the low temperatures are the ones that are causing that missingness. Okay, it's within that domain. And one of the problems about the MNR is that it's not, very easy to detect, because you need to know a little bit more about the process or about how the data. Think about the survey. Okay, you start seeing in a survey, you start seeing that some ages are not, entered. Okay, when maybe when they ask, and it depends. Maybe some people are not comfortable, right? When you are asking in the survey for that kind of information. The same with salary, the same with certain diseases, etc. Okay, so you have to kind of go a little bit deeper and see how that data set was, was made. Okay, so yeah, hot donuts. I like them, Krispy Kreme. Okay, so now that we know a little bit more about that missing data mechanism, why so important, that mechanism? Well, the importance is that some of the methodology that we're going to discuss make some assumptions about these data mechanisms. Okay, we're going to discuss, I hope we have time, I hope to discuss a little bit about, multiple imputations in chain equations and mice. And that makes an assumption that your data is MAR. Okay. Also, for MCAR, for example, for MCAR, you could technically delete those observations. Okay, technically. Okay, because you have to consider also other, other aspects, just the missing data. But technically, you could, delete those observations that have the missing values, because they are random. They shouldn't, add bias, to that operation. That operation shouldn't have add bias to it. Okay, so this one justifies a little bit more the strategy to deal with missing data. Okay, so probably the question that you have right now, okay, and we're going to discuss, this chart, but one of the questions that you have right now maybe is, but how do I determine this? Okay, when my data set, my missing values are behaving like an MCAR or a MAR or etc. So we'll talk about this, but let's take this chart. Okay, and this is basically some of the things that you can do when you are encountering this missing data. The missing values treatment, you can divide it in two major, fields. Okay, you can get rid of them. Okay, deletions, and there's, various mechanisms. You can get rid of, the feature if it has too many. Okay, let's say you have 90% of your temperatures, they're missing. Probably, that feature will be kind of unusable unless you have some justification to try to input those. Okay, then you can drop, the rows where the NAs are, or you can use pairwise selection. Only delete the ones that, those fields that have the missing values. Then we have another category, what is called imputations. In other words, you are going to replace that missing value with a value, right? And then we have within imputations, we have the general kind, okay? General kind and the more advanced techniques. The general kind for non-time series, because remember, in a time series, you should be aware that there are other, other patterns involved, like autocorrelation, etc. And there's some methodology specifically for time series. We're not going to cover those, okay? But I just want to make sure that you understand that the time series have a very different, way of imputation. But for the regular tabular data sets that we encounter, as somebody, mentioned the Titanic, which is one of the traditional data sets that you start, working with it. Well, in the Titanic, you usually have to make an assumption about the ages that are not, represented there, the missing values on the ages. So one of the things that you can do is impute with a constant. Okay, let's say that you have a categorical, feature that has, X amount of labels, and you can choose, right, to impute by the value that is most, frequent or most common. Okay, you can do that. There's some, there's some consequences to it, but you could do it. Then some of the other traditional methodologies for imputation are, imputing with the mean, imputing with the median, etc. Then we're going to discuss one of the advanced methods, which is what is called the MICE method. I'm not going to go into detail, but I'm going to give you some articles that talk about explaining to you how the methodology works. But it's kind of, iterations with a regression. Okay. Any questions so far about this table? Because this table really summarizes basically all the things that you should be doing when treating missing values. Everyone with me right now?
Yeah, just a quick question. Yeah. The KNN base, that's kriging next neighbor?
No, that's the nearest neighbors.
Nearest neighbors.
Okay. Okay. KNN, what it does is tries to, measure the distance of that point within the neighbors. You can, adjust how many neighbors you're going to use, and then try to find a point that is, calculating the minor distances between them. Okay. It's used usually for regression and classification by itself, but you can use it also for imputing. Okay. Yes. Good question. Good question. Good question.
So can you remind us what was MICE?
MICE is, let me give you exactly what it is. Okay. To give you the right, it's the multivariate imputation by chain equations. Okay. It's a methodology that uses, iterable regressions, Anton. Okay.
Right. Yeah.
So try to achieve the best. It creates, imputing data sets, and it creates some random patterns. Okay, and then you have to, kind of pull them together to try to find the best, the best value for imputation.
It's like finding the distributions and
right. Right. Yeah.
Distribution and using that to generate values.
Yes. It makes some assumptions on your data too. Yes. Yes. Okay. Okay. So. Okay. So this was a question that I was, referring to in terms of how can we detect this missing data mechanisms? Well, the only one that I'm aware that has a statistical test is the MCAR. Okay, it's not Python right now. Doesn't have a library that has this statistical test. You have to go to R. Okay, there's a library in R called Naniar. Let me put it in the chat. Let me see. Naniar library. Okay. There is an MCAR test. What it's going to do is that it's going to do kind of a chi-square. If you know a little bit of statistics, that chi-square is used to detect observations versus expected observations, and then you have your p-value, etc. So in that test, what it does is that it assumes that the data set, the missing values are at random. Okay, that's your hypothesis, right? Your null hypothesis. Then your alternate is that they are not at random. Okay, so that p-value, if it goes, usually goes 0.05 or less, then it points to that. Okay. So that in a nutshell, that's what it does. There is no statistical test for MAR or MR. You have to visualize, try to visualize your data. Okay, somehow, do some what is called shadow matrices. Okay, and there's some packages that help you with this, and we're going to see it how it works. Okay, so So this is our data set that we're going to be working right now. It's called the Pima Native Diabetes data set. This data set was collected from members of the Pima, Pima Nation. And it was a study for 5 years where they collected certain, biological, physical information from the patients, and they were trying to study, what are the, what is the onset, or what is the probability that someone is going to get diabetes or not, depending on, the factors that we're going to be seeing. So some of the factors were number of times the person is pregnant. Okay, so you can infer now that some of these members, the survey people were female. Okay, let me go here to give you the whole list of features. So number of times pregnant, we're going to measure the glucose, right? We're going to measure the blood pressure, the thickness of the triceps, okay, the skin, right? Insulin, we're going to measure the body mass, BMI index. We're going to measure the diabetes pedigree, function, the age, and the target will be a class, which is going to say if it's 0, that means that that person is not diabetic, or 1 is diabetic. Okay, so that's our data set. So you read the data set, right? You check, that everything is in order, and you then get this information. And this information tells you right out the bat that there are 768 observations, and you can count the non-nulls, right? You can count the non-nulls, and you're going to see something very interesting here. Okay, this is a description, statistics of the pregnancies, the mean, the minimum values. Some of the values are 0, etc. Okay, so this, in the script, this is a Jupyter notebook. In the script, there is a function for tabulating the missing values. Okay, and it's called missing values table. When you input the data set, okay, the data frame, at the back, or in the original, it says that there are 9 columns. In other words, the target and the 8, predictors. And it says that there are 0 columns that have missing values. Okay. So you are saying, well, wait a minute, no missing values. Okay. So, but I thought you were going to talk about how to handle missing values, right? Okay. So why are you presenting this? Well, you have to go back, okay, and really look very, in detail, this table, the descriptive statistics table. And you see, for example, let's see that blood pressure, the pressure column or feature. Does someone notice something funny there in the blood pressure? Is there something kind of, that it doesn't sound right?
Yeah, 0 blood pressure probably isn't really good for somebody's health.
Exactly. Okay. I'm assuming that, when they interview the people, when they got the measures, they were alive, right? Okay, because the only way that you can get a blood pressure at 0 is when, you have passed away, right? You're not functioning, in other words.
No. Yeah, good observation. No, sometimes the patients, they just remove the monitor switch on their hands, hooked to their hands. This is actually a problem in hospitals when you try to restore the time series. There's no time series because very often they just remove the whole thing. I mean, you see it in the movies, right? Or whatever.
Right. But definitively, a person must have a blood pressure. Okay, if at least if it's still alive, right? We can agree on that, right? So as you can see, glucose also is 0. Skin thickness is 0. Insulin, you have in your system, at least some amount of insulin that helps you, fight, metabolize that sugar. Okay, and also the BMI. The BMI, if it's less than certain percentage, I mean, you are really in critical, you know, in a bad shape. So some of these features, okay, that's what we call columns, you know, in the data science terms. Some of these features, those zeros, what they're telling us is that they represent some missing values, okay? And if we, you know, check the level of zeros, right, within each feature, this is what we get. And as we can see, there are some that make sense that they are zeros, right? For example, pregnancies. Even the females, not all the females are going to be pregnant, okay? So zeros make sense there because it's telling you, okay, that person is not pregnant. But we cannot say the same for insulin, skin thickness, or BMI, because there should be a value there somehow, okay? So those are really the missing values that, you know, they are present in this data set. And it's a word of caution, okay? Missing values don't come as blank spaces, okay? At least most of the time they do, but not always. So you have to be really, you know, kind of, you know, put your Sherlock Holmes hat, because you have to investigate a little bit more about how this data, you know, was gathered, okay? And sometimes, you know, you will have some information about how to deal with them. For example, in some cases in the data sets, it tells you that the NA means this. In other words, there's no garage, or there's no pool, okay, if it's a house, etc. So you have to do a little bit of investigation, kind of, you know, be a little more detailed about these things, okay? So at least we know that there are some zeros, and they should represent, right? They should represent some of the missing values that we're trying to, you know, to deal with, okay? So if we select some of the features that we know that, you know, they shouldn't be zero, we replace it with the nonce. Now we get our missing values for the features that we are, you know, that they apply. And now we can run that function, okay, of tabulating the missing values. And as you can see, the insulin is the one that has the most percentage. It has the highest count, also has the most percentage of missing values, 48.7%. Okay. Any questions, comments? Okay, we're good. Okay, so now that we know that we have some missing values in our data set, this is decision time, right? Should we delete the features or observations with missing values or input them? Okay, you know, making reference to that, you know, to that diagram. We can go with the deletions. We can go with the imputation. Okay, so let's do both. Let's see what is the effect of deleting some of those missing values, and what's the effect of imputing them. Okay, and we can, you know, make a more educated approach to this. So first experiments. Let's see if we can remove all those rows that have missing values. Okay. So we're going to use, in Python, you use the drop NA, okay, function, okay, just like that. It is going, you know, is going to delete, you know, the rows, etc. And we're going to create a new data frame that says df remove rows. Okay. When we see the shape, you see that, remember that we had a total of 768 observations. Now we have a total of 392. In other words, we chopped almost half of our data. You know, we got rid of it. Okay, so that's a consideration that you should be, you know, should be aware. And if someone asks, you know, you should have a proper justification. Better make sure that this data is MCAR. Remember the mechanisms, right? Because MCAR allows you to do this. Okay, the other ones, you are introducing bias to that data. In other words, you are changing the original composition of that data if it's MR and MNR. but let's soldier on. Okay, let's see what happens. So let's fit a logistical regression model. Okay, logistical regression is a regression that allows you to deal with classification instead of continuous numbers. Okay, and what we're going to do, in the function, the model fit, what we're going to do is, doing a cross validation with the traditional logistic regression, no tuning or anything, and the result in the accuracy score is 0.788. Okay, so that doesn't look that bad. Okay, so we have already a baseline. We remove the data, and we have our logistic regression, the accuracy that says 0.788. Just the accuracy. We're not complicating that too much with confusion matrix and anything. Okay. So let's do experiment 2. Let's go to impute the missing values with the median. Okay. Why would you choose the median? Well, some of these observations, if you draw a histogram of the features, you will see that some of the features have skewness. Okay. That means that there's going to be some outliers in some of the features. The median is is a central tendency measure that is very robust with outliers, because it's by rank. It's not by the value itself. It's by rank, and it gives you the middle point of that rank. Okay. So let's input with the median. So this is the script. Okay, fill an A, that's the function that we use in Python for the median, and we're going to create another data frame, but this time, instead of removing, we're going to impute those values with the median, each of the features. Okay, so we get this. For example, in the insulin feature, remember that was the most, had the most percentage, the highest percentage in missing values. We get a figure called 125. If you do a calculation of the median, that's going to be the value of the median. Okay, so for every missing value that is present in that feature, you're going to replace it with that value, 125, and so forth for the other features. Okay, but there is no free lunch here. Okay, there are some consequences to this, and one of the consequences is that you're introducing in your distribution, the region distribution of your feature, you're introducing what is called a spike. Okay, because that's the median precisely. Okay, so you're altering the shape of the distribution of that feature. Okay, and usually that's what happens when you input with the mean or with the median or with the mode. Okay, depending on what is the percentage also. If there's one value, maybe it won't be noticeable. But here you can notice, right? You can notice that spike is the median. So you're altering your feature, introducing some bias there. Okay. Okay, so, but let's run our model. Okay, let's keep on. Let's run our model. And the model, with the median, the accuracy got a hit. Okay, 0.768. Not that much, but yeah, there was some effect in that. Okay, so experiment number 3, and this is the one that is going to use that algorithm, mice, right? Multiple imputations with chain equations. And in the Python world, we have a library. It's called scikit-learn, okay, where it's a companion of basically all the functions that you need to do, machine learning, do pre-processing, do ensemble, all that. So we're going to use what is called the iterative imputer, okay, which is the formulation of mice with scikit-learn. Okay. So this is the instantiate of the function. Is called iterative imputer. We're going to use the extra attributes regressor. You can change the estimator. Okay, you can change it to base regressor. You can change it to random forest, etc. I'm going to use this one, extra attribute regressors, because the documentation shows that this is this is one of the good estimators for this, for this function. Okay, we're going to iterate 100 times. Okay, so we're going to iterate each. It's going to create a couple of data sets. So it's going to create data sets. I'm going to iterate within each data set 100 times. Okay, so it's going to produce, a set of values, possible values for that feature. Okay. All right. So we're going to drop the target, and this is important, right? Because remember, when you are doing the machine learning, when you apply the model, the preprocessed model, to a test data, that test data doesn't have a target, right? You don't know that's what you're going to predict. So you have to remove that target to not gather bias in that algorithm, that imputation. Okay, so you have to drop that target and just stay with the predictors, with those 8 features. Okay, so this is the data frame that we're going to be imputing. Okay, we fit the model, right, with the fit, and then we create our data frame with the transform, right, the fit transform function, which is divided here, and then add the column names. Okay, and you're going to get, after, you have to give some time to this because it's very computer intensive, but eventually you're going to get this imputed data frame. So remember that the experiment number 2 was imputing with a median, right? Okay, so let's compare in the same feature, the insulin, let's compare the values before and after using the imputation with mice. Okay, this is the data frame of the imputed value, and you can see there's a variance in the values. It's not 125 anymore for the insulin. Now you have 205, you have 231, etc. And to do this, now we can see that even though you can see a shift, right? A little shift between the regional distribution, which is the bluish, light blue color, and then a little bit more. But you don't see a spike here. Okay, you don't see a spike. You see more or less a distribution that it conforms with the traditional one. And that's what mice really tries to do. Okay, it tries to impute those those values without altering the original distribution. Okay, so let's see how do we do in the accuracy, right? I'm going to include back the target, append that target. Okay, and then we're going to fit it again. And now we get an accuracy of 0.767, which is lower than the one that we had in the deletion when we deleted the rows, but still it compares very well with the imputation of the median, which was the one that created that big spike. Okay, so conclusions. What do we learn today? We learned some of the mechanisms to diagnose, the causes of missing values, MCAR, MAR, and MR. We discussed some of the alternatives with delete and impute. But there's a third alternative that I haven't mentioned yet, okay? And I want you, that's an assignment for you guys, okay? There is a third alternative that doesn't impute deletion or imputation, okay? And it's very clever. So let's try to discuss that in the Discord channel. And I give you some hints there. Okay, you have to check your data set, before assuming that do they contain missing values or not, because they can appear as zeros, sometimes can appear as -1. Also, I've seen it, or appear as a very large number, 999. Okay, that's one that I encountered like a couple of months ago. So check the documentation of the data set. Check, some patterns that you see that they don't fit. In other words, they don't fit with the reality. Also, be careful when using the mean, median, and mode imputation. Usually what you're doing is altering your distribution variance, okay? And that's not the best practice right now, okay? You can do better. You can do better than that. Okay, so any comments, questions?
I'll stop the recording here.